Domain and range, page 7, okay? This is a concept that you should have been exposed to in the intro course. If you didn't take intro, then this is gonna be very new to you. You're gonna almost find that this is weird stuff, right, that we're talking about. So page 7, I didn't talk about it at first because I wanted to focus on just how to graph, how to sketch. But the domain and range of a quadratic function, this is in particular for non-contextual graphs. What does that mean? No word problem. This only applies to questions that do not involve word problems. How do you know there's no word problem attached to it? There's no text. It's just like, here's the equation, graph it, okay? So, for the domain, I'm going to use a different color for domain. I'm going to use a different color for range. Okay? For the domain, what does the domain tell us? It refers to all permissible x values. Okay? All permissible x values. All the x values that are acceptable in this situation. Okay? When it comes to set notation, there's always two ways to note this, two ways to express the domain. Set notation, interval notation. Set notation, you always want squiggly brackets. Okay, so make a little note. It should always have the squiggly brackets at the beginning and at the end. And interval notation may have a combination of round brackets or square brackets. Okay, so you got to understand that in a bit. I will explain that a bit more, but that's what interval notation talks about. For the domain, when it comes to x values, this setting right here, x belongs to the real values, right? It says that all values of x are part of the real numbers. What are real numbers? Any number that you can possibly think of. Decimals, fractions, negatives, positives, any number that you can think of is considered a real number. Okay, so that's basically saying anything goes. Interval notation, if you wanted to translate this to interval notation, you're saying where are you coming from the left of the x-axis and where are you going to on the right side of the x-axis. So it would be negative infinity to positive infinity. And just so you understand, I'm going to do a little grid here. When it comes to the x and the y, right, this is negative infinity. Like if you just kept going to the left, you'd get to negative infinity. Once you get there, let me know. I want to know what it's like. And then negative infinity for the y would be going right to the bottom. Positive infinity would be you're going to the top. So x goes from negative infinity to positive infinity. Y goes from negative infinity to positive infinity on the grid. Okay. So the domain is easy for now. The domain is always going to be, I'm not going to make you use one over the other, but I may ask you, is this the domain of this function? And you have to recognize it, that this is the one for a non-contextual parabola. And or this is the interval notation. Notice that we use round brackets. We never use square brackets around infinities. Okay? Next, range. I'm going to use green for that one. Range is a little bit more complicated in this case. It's all the permissible y values. All permissible y values. So imagine this. You've got two versions of the parabola. One is pointing up, one is pointing down. This is your domain. Right? It tells us all the permissible x values. I'm going to use the same color I used for domain here, and I'm going to go to the next graph and say, in this case, the best way to look at the domain is sideways down here. And because both of these graphs have arrowheads, right, for the domain it goes from negative infinity to positive infinity. That's how we wrote it like that. Same with the second graph. It goes from negative infinity to positive infinity. Okay, so that's your domain. For the range, it's a little different. The range goes from here and just keeps on going up indefinitely. On this side, it goes from here, it keeps on going down indefinitely. So I'm going to make a dashed line to the vertex. So you need your vertex to state this properly. And so the range is different. What would the value down here be like this? The lowest y value we accept would be the y value of the vertex. Is the lowest y value we accept, and then it goes up from there if it's pointing up. Okay? If it's pointing down, then it goes from the y value here. In this case, the y value is the upper value, and it goes to negative infinity from there. So that's how you have to understand it, envision it. So for set notation, for this first case here, okay, set notation would be squiggly brackets, y is greater than or equal to the y of the vertex. That's all I'm going to say here. Squiggly brackets. Example, I'm going to give you an example right here. Okay? Let's say this is pointing up, and the coordinates of the vertex is 2, -3. Since it's pointing up, you should right away know, okay, the y values that are acceptable here would be greater than or equal to the lowest y value, which is -3. That's it. There's your example right there. When it comes to interval notation, let's see, you go from the y of the vertex to positive infinity. And remember, infinity never gets a square bracket. It cannot be contained. So you always put a round bracket around it. So example, you must understand that this is pointing up. If your vertex is 2, -3, let's stick with 2, -3. And you see, oh, okay, this is pointing up. Then you will say that the lowest y value is -3, and the highest y value in this case is infinity. So there is no variable in interval notation. You just say start, finish. Okay? Start, finish. That's all you do. What if it's pointing down? If it's pointing down, then it obviously does this. So for set notation, we would go y is less than or equal to the y of the vertex. So getting the vertex is going to be crucial for your range. You need to figure out the vertex to be able to do the range, okay? So in this case, let's do an example right here. If it's pointing down, and let's say this is -5, 7, 10, let's say. And I ask you, what is the range of this function right here? You would say, oh, first of all, it's pointing down. Therefore, it's going to be y is less than or equal to the y value of the vertex. There we go. That is how you state the range for that function. If it's an interval notation that you're interested in, then it would be, it's a little counterintuitive. You're coming from negative infinity and you're stopping at that highest point. So we go from negative infinity to the y of the vertex. And the y of the vertex gets a square bracket around it. The negative infinity will just not. So if you ever have this happening, let's stick with the same coordinates of the one above there. Negative 5, 10. Right? You're coming from negative infinity down here. Right? You negative infinity and you stop at the very highest value that where the graph stops. It doesn't exist past 10. Okay? It doesn't exist past 10. So for the domain, we usually go from left to right. We read it from left to right. For the range, we go from the bottom up. Okay, that's how we kind of view this. Okay, so note down here. Note smallest first for domain and range. For domain and range. In interval notation, I prefer interval, to be honest. That's the one I'm going to use most often. I'm not going to use set notation a whole lot. For domain and range, in interval notation, it's always smallest first, comma, largest second. So some students grab the right numbers, but they mix them up because they're like, wait a minute, like which one should I put first? Just say largest first, smallest first, largest second. So example, let's say you put the range and you want to state what the range is. Usually go R and then state it. So let's say you do this one. 10, negative infinity. What's wrong with that? Which one is the smallest of the two? Negative infinity. So this is wrong. Okay? So this is what you should be doing. Negative infinity to 10, like that. That is correct. Okay? So that's what I'm trying to say there. A number gets a square bracket. Infinity gets a round bracket. So, I know this is a lot. You haven't seen this in a while, so I understand that. But I want to recap one more time. For now, this is what you kind of need for your range. But please don't just copy this box down. Have a diagram, either these diagrams or you just include the examples. Because this one right here includes it pointing up, A being positive. This one is when A is negative, okay? And you need the vertex, okay? I should add that somewhere here. Need vertex, nice and big here somewhere. For the range to work, you need the vertex. You need to figure it out. If it's not given, you need to figure it out, or else you cannot answer it properly. I'll give you a little short version of this later on, a little cheat in the front of this booklet, okay? Maybe I will do that right away because I know I tend to forget these things. So let's go to the front of the booklet and just have a summary of this. Like you can make it better You can make it customize it to what you need. Try it out with ACs that are coming your way. If it doesn't do the trick for you, you might have to be a bit more specific. So let's go to the front. I will say this, domain and range no word problem. A few exclamation marks there, because I don't want you to mix this up with word problems when they come down the road. Then things change. There are very few infinities when it comes to that point. Okay. Okay. So domain and range. So I will just say this: domain is usually X is all reals, or domain is negative infinity to positive infinity. That's just what it is. It doesn't matter which way it's pointing. It just keeps opening up sideways indefinitely. It just opens up and never stops. If there's arrowheads on both ends, then this is what it is. Okay. For the range, it changes. So I'm going to give you two graphs here. If it's pointing up like this, and let's just come up with a new number here. 3, -7, let's say. You figure out what the vertex is, and it's 3, -7. Then for set notation, it would be y is, it's from -7, that's the lowest, and it keeps going up to infinity, right? It's greater than or equal to -7. Squiggly brackets. Or, how would we do this? We go from -7 all the way to positive infinity. Like that. So that's how you deal with that one. And another case here, I will say this. A is positive. That's basically, when A is positive, you're in that camp right there. And then if A is negative, it changes, right? Range. Let's do the squiggly brackets. Let's have a graph right here. And let's go -10, 30, let's say. That's the coordinate of the vertex there. Since it's pointing down, we would be y is less than or equal to 30. Or range is, what are we going to start with? We're going to start with negative infinity, and then we reach the top, which is 30 square brackets. This is if A is negative. Box this whole thing in. It's kind of like your domain and range. I made it too big, to be honest. It shouldn't be taking up this much space. Maybe you can, obviously you can make it a lot smaller, and maybe the graphs can go like in front of, like this graph could have gone like right here, squeeze it in right in front and then just have one line. And same with this one, I put the graph right in front and then just squeeze in, just have one line. This should not take up this much space, but I just wanted to make sure you have like a summary of domain and range. Okay, so from now on, I'm going to ask you to state the domain and range quite often, actually. Let's go to page, spend a few minutes on this. So look at these graphs. There's just one flaw here, okay? That these should have arrowheads. They don't stop. So basically, if there isn't like a solid dot on one of the ends, we're assuming this thing keeps going, okay? So state the domain and range both in set and interval notation, right? So for the domain, it's easy. That one you can just copy paste. For the range, you have to think what's happening here, okay? And sometimes you have to read the vertex off of the graph. So take Take a few minutes and try that, okay? For the domain and range, for the first one, you can, for now, feel free to just, without much thinking, you just say, well, this one never stops, so it just keeps opening up indefinitely, right? Sideways. And so for the interval notation, it would be this one. Okay, so no problems there. When it comes to range, you got to look at your little cheat sheet there in the front. This one is pointing down, right? It's doing this. So it'll be y is less than or equal to the y value of the vertex, which is 2.749. Just make sure you put squiggly brackets around it. When it comes to interval notation, it goes from negative infinity, right? You fill up the cup all the way to the top. So this one gets a square bracket, this one gets a round bracket. Okay, so that's the domain and range in this particular situation. I will only ask you for one of them. So let's say you like set notation, then I would just expect you to state that, domain and range. If you like interval notation, you would just state it like that, right? I'm not going to expect you every time to do all 4 versions of this, but it's good practice. Over here, for the domain, go for it and just do this. Okay? When you work with the range, you need to figure out your vertex. Okay, you need the vertex here for that one. It's pointing up. So the y values will be greater than or equal to 1. That's it. The y value of the vertex. And for the range, it'll be 1. That's the lowest all the way to infinity. And what you're telling your audience is that, hey, is -2 is a permissible y value for this particular function? No, there's no graph, right? It's only once you get to 1 and higher that you're going to see the graph. That's what you're doing. Let's keep going. Page 9, without a graph. I don't know if you graphed it. I didn't graph it on my version here. But we don't really need to graph to figure out the domain and range. So the domain, let's write this down here, is just this. Or negative infinity to positive infinity. This is on page 9. Okay? For the range, which one is this going, this graph? We already determined it up here. It is going down because a is negative. So we know this is what we're expecting here. And we know the vertex. So this is going to be y is less than or equal to 112.5, like this, or negative infinity to 112.5. Square bracket, round bracket. Okay. Make sure you copy that down so when you flip through it, you can determine that. What I will do for you is down here, just make one of these and tell yourself that that is the vertex, which is 25, 112.5. Then you can quickly make reference to it. It's like, okay, that's why we came up with that domain and range. Okay? Next one. This one over here on page 10. Okay? Just based on this equation, we figured out the vertex already. Okay, we figured out the vertex. So, how do we state the domain and range for this particular function? We know it's pointing up because a is positive. We know this vertex location here. Okay? We know that vertex location. So the domain, I'm just going to stick with writing the same thing every single time for now. For the range, it's y is greater than or equal to -7. That's that. Or you go from -7 to positive infinity. That's how it goes. Okay. And let's do the last one on page 11. Oh, you were still copying. Go for it. Right, page 11. This one we did graph, but here again, my domain is x belongs to all the real numbers, or you could say negative infinity to positive infinity. Interval, think of interval as like, where are you in between? What's in between, right? And my range, this one is pointing up, so I will go greater than or equal to. I already determined that the y value of the vertex is negative 132.50. That's what you write down there. Or negative 132.50 to positive infinity. Either one will do the trick. Okay? All right, that concludes our domain and range talk.